In this video, we will be talking about the collision objects in the soft body simulation. Now, the collision objects are objects that the soft body can interact with and collide with, and it is located over in the physics panel right here. Once you click on it, it applies a modifier to it, and you can see the modifier in the modifier section. Now, over here on the right, these are the options for the soft body, and over here on the left, these options are for the particles. We won't be talking about these since it doesn't apply, but we will be talking about the ones over here. The first two options are the inner and the outer. These two are just the values for the invisible walls that appear around the object. So currently we have this plane right here. Let's go into front view and we'll play it and see what it looks like. And you can see it hits it and then bounces a little bit. Now this value, if we play it and we just wait for it to stop bouncing, if you zoom in, you can see there's a small gap in between the plane and the sphere. If you have lower values than 0.02, the soft body might clip through it or it might just fall through. So be careful with lower values than this. If we turn this up and we play this, you'll see that the invisible wall is now probably over here somewhere. So if we play it, you can see it stops it way above the plane just like that. The inner is very similar, except it's the inside of the mesh. So I'm going to delete that, then press Shift A and add in a cube. I'll go into front view and I'll scale this cube up and place it inside of our UV sphere. I'll add a collision object and I'll set the inner to a value of 0.02. Now if we play this, you can see that the icosphere just falls straight through. That is because we need to add a solidify modifier to this, this cube. I'm not sure why you need to do that, but I can't seem to get it to work without it. So what we need to do is go over to the modifier tab, click add modifier, and add in a solidify. We'll turn up the thickness just a little bit, and you also need to make sure that the solidify is above the collision. So we'll drag that above it, then let's press Alt A, and you can see it's now interacting with it inside of the cube. The next option that we have is the soft body dampening. This is the amount of dampening that will happen during the simulation. For example, we have two cubes right here and two planes. This plane has a soft body dampening of 0, and this plane has a soft body dampening of 1. You will see the differences once I play this, so I'll restart the animation and play it. And you can see this one's bouncing a lot more, and this one just stops immediately once it hits the plane. I'll play that one more time so you can see the differences. There we go. The last setting that we have over here is the force field absorption. Basically what this does is it will stop the force fields or wind or whatever force field that you have from interacting with the soft body physics if it's in front of it. So for example, right here we have this collision object with an absorption of 1, and behind that we have a wind force field, and then we have a flag sort of simulation right here. Let's get rid of this cube by just moving it over here. Let's play it and see what it looks like. So you can see the wind is interacting with this simulation, it's pushing that way. Let's restart this, we'll drag this over here, and we'll play it one more time. And as you can see, it's not affecting it. That is because the collision object is in front of the wind. With the absorption to 1, it totally gets rid of all of the effects, but if we go, let's say 0.5, only 50% of the wind will actually get through this object. Another thing to note is you need to select the collision absorption in the force field settings. If this is unchecked, it's not going to have any effect. It will still go through it even though we have this set to 50%. We need to make sure this is checked on for it to work properly. So there you go, that is the collision object. Thank you for watching.